In 9.4, we're going to look at how to use square roots to solve quadratic equations. First, we need to isolate all quadratic functions into the form of x squared equals to d. There's going to be three cases. Let's look at the case when d is greater than 0, meaning positive. So when d is greater than 0, the quadratic equation x squared equals to d will have two solutions. So when I take the square root of both sides, I would get positive x equal to positive negative square root of d with two solutions. So let's look at an example here. So my goal is to isolate x squared. Therefore, after solving this, I would get two solutions, positive, negative 3. And for the second case, when d equal to 0, there's only going to be one solution. Again, let's look at an example. So one solution, 0. Now let's look at the third case when d is less than 0, meaning negative. So I'm just going to put a negative sign next to d. And for x squared, this would always produce a positive number. So this is not a true statement. X squared equals to negative d does not make sense. So therefore, it's no solutions in this case. Let's look at another example. So again, this doesn't make sense. So no solution. Guided practice. Solve the equation. Write your answer in simplest radical form if needed. Okay, let's look at this first example here. So I'm going to take the square root of both sides because my goal is to isolate the variable. Positive, negative 7. Now you have two cases. T minus 5 over 3 equals to positive 7, or t minus 5 over 3 equals to negative 7. And this would be t minus 5 equals to 21, and t equals to 26. And this would be t minus 5 equals to negative 21, and t will be equal to negative 16. For the second one, x squared, and we could move negative 2.56 to the right hand side and change the sign. And now we could take the square root of both sides, and this will be x equal to positive negative 1.6. And for this one, we can do x minus 6 squared equals 64. So first factor the trinomial on the left hand side, and then we can take the square root of both sides, cancel out, positive negative 8. So x equals 6 plus or minus 8. So we have two answers. 6 minus 8 will be negative 2, or 6 plus 8, 14. For this one, I will take the square root of both sides first. So this will be 4m squared minus 6 equals positive negative 9. So now I have two possibilities. 4m squared minus 6 would equal to 9, or 4m squared minus 6 would equal to negative 9. Now this would be 4m squared equals 15, and m squared would equal to 15 over 4. Square both sides. This will be m equals square root of positive negative square root of 15 over 2. Okay, remember, you cannot have a square root in the denominator. It must be in simplest form. And then this other one, 4m squared, so we add 6 to both sides, we get negative 3. Now, m squared would be negative 3/4, and remember, the square cannot become a negative number, so in this case, we just ignore this part. So your solutions will be positive negative square root of 15 over 2. And then for this one, let's first add 20 to both sides. Cancel. 121. Now I'm going to take the square of both sides again. So this will be t minus 7 equals positive negative 22. We have two possible answers. T equals 7 positive negative 22. So t is either negative 15 or positive 29. Let's take a look at this one. Okay, I can first take the reciprocal of 1/5. Cancel it out on the left hand side. And now I'm ready to square both sides. So z would equal to negative 3 plus or minus square root of 35. And you can just go ahead and leave your answer like this. It's already in simplest radical form. Okay, let's look at this part. We need to isolate this part of the quadratic function. So I'm going to add 5 to both sides. Then I'm going to divide 2. And then I'm going to square this. Now, this is not in simplest form. I'm going to show you how to rewrite this in simplest form. But let's first continue with solving for x. Negative 2 plus or minus square root of 13 over 2. Now we need to make an extra step to do this. Because it's square root of 2 in the denominator, I need to multiply by square root of 2 over square root of 2. Therefore, x would equal to negative 2 plus or minus square root of 13 times square root of 2, which is square root of 26, all over square root of 2 times square root of 2, which is still 2. So this is your answer. And for this last one here, I'm going to clear the denominators. Between 4, 2, and 3, the GCF is 12. So I'm going to multiply both sides of the quadratic function by 12. So cancel, this is 3. So 3 times x minus 2 squared. plus 2 cancels out, so 6 times 3 makes 18. 3 cancels out, 4 times 5, 20. Okay, now I'm ready to isolate this part of the quadratic function. Subtract 18 to both sides to get 2 on the right hand side. Now I'm going to divide 3 to both sides. Take the square root of both sides. So x minus 2 equals to plus or minus square root of 2 over 3. X equals 2 plus or minus square root of 2 over 3. But we're not done yet because this part of the answer is not in simplest radical form. So I need to multiply this by square root of 3 over 3. And there you have the solutions. Use the given area A of the circle to find the radius R. So the area here is given as 144 pi square inches. And the area of a circle is pi r squared. So I'm going to set that equal to 144 pi. I can cancel out pi, so r squared equals 144. I could take the square root of both sides, and r would equal to positive negative 12. Well, there's no such thing as negative distance, so we can go ahead and ignore the negative sign, and the radius will be 12 inches. Okay, and the next one would be to solve the equation a times x plus b squared equal to c in terms of a, b, and c. So again, we're trying to solve for x in terms of all the other letters. So I'm going to divide a to both sides. Now I'm going to square both sides. X plus b will equal to positive negative square root of c over a. And x would equal to negative b plus or minus square root of c over a. And earlier I said that we're not supposed to have a square root in the denominator, but in this case you could just leave it like this. Word problem. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? Write your answer in simplest radical form. The model for dropped objects is h equals negative 16t squared plus the initial height. Remember in chapter 8, for dropped objects, there's no initial vertical velocity because the object does not travel in a parabolic path. So now we can set up this equation here. So this egg is dropped from a height of 50 feet. So this is our initial height. And how long does it take the container to hit the ground? So this is our final height, h. So h will be 0. And we can substitute the initial height of 50 for h sub 0. And now I'm ready to solve for t because I need to find the final time. Then take the square root of both sides. Well, we can't have a negative time, so I'm just going to go with the positive answer. And let's simplify this. Okay, I'm going to show some extra work to refresh your memory. So we can take out this perfect square 25 and 16 to the outside. So there would be 5 square root of 2 over 4 seconds.